Hey everyone, this is Patrick. Today I'm going to show my implementation of the K-means clustering algorithm inside Maya using Maya nodes and objects as tools for visualizing the algorithm. I've been interested in machine learning recently, and I've been reading up on K-means clustering as one of the algorithms used to classify random data points into groups. Because of diagrammatic explanations like that, I managed to understand what the K-means cluster algorithm is trying to do. So what happens is you have an unclassified and uncategorized random distribution of data points, and then predefining the number of clusters that we want, we put them randomly and distribute them across the space of the data, and then using that we go through each of the sampled data and find the closest cluster that belongs to and associate itself with. So very quickly we get associations like that, and then we move the centroid of the cluster to the center of the associated nodes. By moving that, we re-evaluate the distance of each of the nodes to that new center, and we get a more optimized kind of distribution around the clusters. So we keep doing that until we don't get any improvements or any movement from the cluster handles, and that is the optimum position in local space. Example of data like that graphed across two different axes based on two different input. If we wanted two clusters, this is one way that it could classify the data. So going to my code, I wrote my algorithm in Python. In my code there's just two things: scattering the nodes and scattering the cluster handles, and then the K-means clustering function. So the first thing is I initialize and define the grid size 15 units in a positive and negative in all axes for spreading and randomizing my data position, and it's going to be represented by cubes, 100 of them. Let's run this one. I'm going to turn off the home grid now. And then the next thing is using the exact same scatter nodes. I scatter my 6 cluster points and visualize with spheres. I'm going to give them random colors. Random that. So this is totally random. K-means clustering algorithm. It's automated, but I can also step through it if I turn this off. When it's automated, there's a delay in the animation, so I can control that. So every node gets tagged with the color according to the distances. Okay, and then you can see that the centroid of each of that gets moved in every iteration, and that association and color coding changes as well as the distance from the cluster center changes as the cluster center moves. So at the 4th and 5th iteration, there was no change in the position of the clusters after all that evaluation, so the iteration stopped. So that's what the code is doing. So delete. Let's try 612 clusters. As the number of nodes and data points increase, it's going to take a long time, so I'm going to put no pause and just going to run that through. And you can see many number of points, but Maya seems to be taking it well. I tried 2000 and it was, well, it really slowed down at the point. So I think it slows down because it goes through each of those nodes and evaluate distances every iteration. Okay, so it stopped at like 20 iterations. It's interesting because Wikipedia talks about it would lead to Voronoi cell kind of distribution, and we're starting to see it here with 600 nodes. Voronoi in computer graphics and visual effects is a way to fracture our geometry, and so it was a surprise to me that it's leading in that direction. So that's what my code is doing, and thank you for watching.